Hello friends, my name is Dara and this video is created with a purpose to give you a simplified walkthrough on Java design patterns. Before we get started, let's look into the agenda. In this session, we are going to go through the design pattern definition. We'll look into the architecture versus design pattern topic, and then we move on to why design patterns. Moving on, we'll look into the types of design patterns, and then we'll look a brief into the types of creational design patterns, structural design patterns, behavioral design patterns, and some of the Java Enterprise Edition design patterns. Now let's look into the design pattern definition. So in simplified terms, design pattern is a general repeatable solution or a template to common or usual occurring problems in the software design. A design pattern isn't a finished design that can be transformed directly into code, and rather it's a description or a template to solve a problem that can be used in many different situations we face in the software design. Some of us might have this question on what is the difference between architecture pattern and design pattern. So let's quickly look into these two definitions and what they cater on to. So when we talk about architecture patterns, they are the ones who are usually addressing the high level definition and the structure of the solution, whereas the design pattern, they cater on to low level scope to help detail and design the solution. The architecture pattern defines the way components are organized and assembled and the way they communicate, and the design pattern in turn helps in defining how components are usually built. Moving on, let's look into the next important question we might have. Why exactly design patterns? So basically, I think the idea of design pattern is to give us good structured and robust code, and it enables that via using the proper class creations, the proper instantiation of classes, and the interaction between the objects. It also helps to enable loosely coupled and reusable code, and at the same time reduce the total cost of ownership and the low maintainability. And in summary, they just help to us to create an efficient software. Types of Java design patterns. The famous Gang of Four gave us the 23 design patterns in 1994 via their book Design Patterns, Elements of Reusable Object-Oriented Software. These 23 design patterns are of three categories. The creational design patterns, which deals with the object creation. Structural design patterns, which help to form the large object structures between many disparate objects. And behavioral design patterns, which are used to manage the algorithms, relationships, and responsibilities between objects. This slides give the complete list of the Gang of Four design patterns. On the left hand side you see the creational design patterns. There are 5 of them. In the center you see the structural design patterns, 7 of them, and on the right hand side you see the behavioral design patterns, 11 of them. I'm not going to list down and spell out all of these 23, but I'll make some mentions here, which are the popular ones and some of my favorites. For instance, singleton, factory, and builder ones from the creational design patterns, adapter and composer from structural design patterns, and template method, chain of responsibility, observer, strategy, and state from the behavioral design patterns. Moving on, let's look into the creational design patterns. As discussed earlier, there are 5 of them: singleton, factory, abstract factory, builder, and prototype, design patterns. Let's talk about some of them. The singleton design pattern basically is used when we want and help to ensure that only one instance of a class can be created. The factory design pattern takes out the responsibility of instantiating an object from the class to a factory class. And talking about the builder design pattern, it allows for a dynamic creation of objects based upon easily interchangeable algorithms. Moving on, let's look into the structural design patterns. There are 7 structural design patterns: adapter, composite, proxy, flyweight, facade, bridge, and decorator. Talking about a couple of them, for instance, the adapter design pattern, it permits the classes with disparate interfaces to work together by creating a common object by which they may communicate and interact. The composite design pattern, for instance, is used when we have to implement a part-whole hierarchy. The proxy design pattern helps to provide a surrogate or placeholder for another object to control access to it. Let's now talk about the behavioral design patterns and discuss some of them. There are 11 behavioral design patterns: the template method, mediator, chain of responsibility, observer, strategy design pattern, command design pattern, state design pattern, visitor, interpreter, iterator, and momento design pattern. The template method design pattern is used to create template method stub and differs some of the steps of implementation to the subclasses. The mediator design pattern is used to provide a centralized communication between different objects in a system. Chain of responsibility design pattern gives more than one object an opportunity to handle a request by linking receiving objects together. The observer design pattern lets one or more objects to be notified of state changes in other objects within the system. Strategy design pattern, for instance, is used when we have multiple algorithms for a specific task and the client decides the actual implementation to be used at the runtime. The state design pattern is used when an object changes its behavior based on its internal state. After going through the creational, structural, and behavior design patterns, let's give a quick look into some of the Java Enterprise Edition design patterns. Java Enterprise Edition design patterns are concerned with providing solution for the Java Enterprise Edition applications, and below are some of the popular design patterns. MVC design pattern. As we know, MVC stands for the Model View Controller. An MVC design pattern is commonly used for developing user interfaces, which divides the related program logic into 3 interconnected elements in form of model, view, and controller. The dependency injection design pattern allows to remove the hard-coded dependencies and make the application loosely coupled, and then the dependency resolution is moved from compile time to runtime. The data access object or DAO design pattern is basically a template to reduce coupling between the business logic and the persistence logic. With that, we have covered the intended agenda and we have come to the end of our session. Hope you liked it and had some learning out of it. Thanks for your time and interest in the session. Have a great day and keep learning. Thank you.